Hi, everybody. So my name is Idit Levin, and I am from EMC, in the CTO office, and also the CTO of EMC Dojo. So what I want to talk to you today is a session about advanced development project that we did. It's called Unik, and it's about Unikernel. So let's start and see how it's connected to Cloud Foundry, it's connected to Spring, and all of this together. So first, let's understand the motivation of why we did this project. So if we look into the virtualization stack, specifically when you're running it on Cloud Foundry, that's your stack, right? You have a hardware, then you have your hardware drivers, then you have your hypervisor, then you have your virtual hard drivers, then you have the OS kernel, then you have the OS user processes, then you have in Docker that it's kind of the same like US processes, but just more isolated. Then you have the shell libraries inside the container. Then you have the language runtime inside the container. Then you have your application inside the container. And then eventually you have the application config inside the container. And if we're looking at all this stack and trying to understand what is the why do we need all of this? We need to remember that basically we're trying to do something that is very, very, very simple. We try to run a single application with a single user on a single server. And if you look at this, it's a little bit of overkill. If you're looking at a lot of those layers, you will see that there is a lot of redundancy. For instance, isolation, it's a good example. So you have the isolation of the hardware layer, which is physical isolation. Then you have the hypervisor isolation, which is separate your machine. Then you have your OS user processes to separate your processes, Docker, who kind of doing the same thing, and then eventually your application will separate your user. And the kernel, the Linux kernel that we're using today, it's very complicated. And when you're trying to understand why it's so complicated, you need to remember that the main reason that it exists is to protect, right? And what it's going to protect, it will protect application from application, it will protect user from user, and it will protect application from user. The real question, does it really need it today? So that was very makes sense. It seriously makes sense when we were like on the 50, 60, and people were building this, buying this huge mainframe, and that was very expensive, right? We couldn't run one application of it. We needed to actually use the model of time sharing, and therefore we need a way to actually protect, right? But we're not doing it anymore today, right? Today you can actually easily dedicate a virtual machine, and that's it. If we're looking at a lot of unnecessary stuff that you have today inside the Linux kernel, you will discover that you have drivers like floppy, for instance, which no one is using it, but we still have the bit and byte on your machine. Same thing, USB driver. You're running on AWS, you cannot get to the machine, you're still going to have this driver, right? So there's a lot of unnecessary. And the last thing is that if you're looking today in the model of updating, so you have like the YAM update or the get up, it depends when you're actually running. Again, you're getting a lot of junk to your machine. Some of them you don't even need, it's still going to be there. And in terms of security, so the surface of attack is huge, right? I mean, you can SSH to the machine, and you have a lot of ability to actually attack the machine. Linux is very popular, therefore there is a lot of exploit against it. And the hypervisor, if you're running on hypervisor, and the reason I will say that it's because Unikernel is using it, it's usually behind the firewall, so it's not exposed to the internet. And that's important in terms of security. I will explain in a second why. And the last thing is that if you're looking at microservices architecture, they are sharing a lot of stuff, right? You're sharing a kernel, and you're sharing a memory, and you're sharing a file system, and you're sharing hardware. And the only thing that basically protects you is this little extension to the kernel called cgroup. And it's kind of like you will take a big house, and in this big house you will have windows and doors, and you will put a lock. Still, people will be able to probably get in. So Linux kernel, it's very, very complicated, the kernel. If you're looking at the amount of technology that you need to know in order to maintain one, it's going on and on, right? A lot of technology you need to know and understand, and language in order to support that. I would argue that there is not a lot of people in the world that actually know what's happening there. If you're looking at the source line of code as a parameter, how complicated it is, I will say that small application is kind of like 10K lines of code. Medium to large, it's something like 100K line of code. And really huge one that there is a team that's maintaining it, it's around 1 million line of code. This is the line of codes of the Linux kernel today. It's 22 million line of code, right? This is only the kernel. We are not talking about the distros, right? This is the Ubuntu distro, the Debian distro. This is 419 million lines of code, right? In order to understand what the hell is happening there, make sure that you can actually, if there is a bug, you fixing it the right way, you prioritize it. It's very, very hard to reason about. So what I describe right now is a lot of inefficiency of what we're running today. And the real question is, how did we get there? And what I will argue is that it's just a pure evolution. We started with the main computer, we went all the way to the personal one, go all the way to today, Internet of Things, small device. But the only thing that was common to all of those are Unix, right? Unix was there to support us all the way. What can Linux run on? Anything. What can run on Linux? Anything, right? I can take 10 years ago, Pentium 1, take the last Debian distro, and just run it out of the box. It will work. I don't need to configure anything. So we basically created a trade-off as a community. It was more important to us to make sure that we support compatibility versus efficiency. And this is what we make it as a community. So we make it work, right? It works, and it's running, and it's all good. But now I suggested that we'll make it right. And after it, hopefully, we can make it also fast. And this is why we really, really like the Unikernel architecture. So just quick, what is the difference? What is the traditional approach? So in the traditional approach, you have the kernel itself. On top of it, you have all those libraries. And then you're putting the application. No matter which application you're running, that's always going to be on your machine. You need all of this, no matter if your application will need it. What Unikernel architecture is doing, they're saying, if I don't need it, I'm not going to put it on the machine. And that's exactly what you will see here. So the approach is, I'm going to take only the bit and the byte from the kernel form of the libraries that I actually need to run my application. Only the drivers that I need. If I'm running in Zen, it's different than when I'm running on EXSI. There is no good reason that both of them will be, right? So how does that work? You're taking your application, dependency, your config, your binary. You're taking your language runtime, and you're taking your drivers, putting all of this in this magic tool, packaging tool, and you're getting a unikernel. And what is a unikernel? It's basically a bootable image. So you can run it on an hypervisor. You can run it on bare metal if it makes sense. It's basically a bootable image. And it's also, right, it's its own entity. So you can have your own network stack and just VM, right? So what did we do? We just reduced what we don't need. We don't need those layers. There's no really need that it will be there. So let's summarize real quick what is the Unikernel advantage. The first one is there is no other user. There is one user support. You're getting at the login at the admin, and that's it. In terms of permission, there is no permission check because there is only one user. And therefore, you don't need to do any context switch. By the way, there is no virtual memory. There is only memory, right? The regular memory. And besides that, if you're not doing all this context switch, and you're not also doing the kernel mode versus a user mode, you're getting huge performance because you're not changing all the time. You're not questioning. You're not doing all these things that actually taking your performance. So you can actually utilize 100% of your hardware and your resource to your application, not to your operating system. So in terms of isolation, it's only on the virtual machine layer, the virtual hardware layer. You're sharing only hardware. In terms of size, if you were taking a regular distro of Linux, putting it on VM, we're talking about, I don't know, 1 gig at least. If you're talking about Unikernel, it's tiny, it's K size. So basically, the size of your Unikernel is the size of your application. Because there is not a lot to boot, the boot time is very quick. So that's as performance as container, right? Because there is not a lot of line of code to actually perform. And the last thing is that the surface of attack are tiny, but it's also customable. So if I'm running this application on this unikernel, I will get a different unikernel. So even if someone managed somehow to get to this unikernel and sabotage that, it will not be able to do that to the others, right? So that's the cool thing. I mean, there's two types of unikernel. One of them is POSIX compliance, which means that you can run most of your applications that you know today, like we're running C++ and Java and Node.js and, I don't know, name it, and Go and whatever you want it to run. And there is language specific, which like, for instance, Mirage.os, it's a good example. Docker does acquire a company called unikernel.org. They are specialized in Mirage.os. And what they're basically doing is saying, if you want to run a very, very performable unikernel, you need to run it on OCaml. Not a lot of people running OCaml, therefore, not a lot will use it. So now what did we do? So I went on and tell you what I think that the future, or not the future, in the future, there's going to be only also a space for unikernel. And the question is, why not a lot of people adopted it, like I think that they should. And when we thought about it, I thought that the reason is because it's hard to use, right? I just described you right now. We need to take driver, we need to compile it, user mode. It's very complicated. Not everybody has this ability to do that. And that's exactly the problem Linux container had before Docker took it and make it very easy to use. So that's basically what Unik is. Unik is a Docker for a unikernel. We're doing all the work for you. It's a little bit more than this because we also kind of like went a little bit higher, and we're also helping you to actually stage it on your provider. So how does it work? Very simple. Unik build, Unik run, very, very simple, right? I mean, I will show a demo, so let's go quick on it. So this is the most important slide for my opinion. What's special about this slide is that when we did it, it was very important to us not to be opinionated. We felt that this is very, very important if we want to merge a community around it. So we were very inspired for the Kubernetes architecture, which means that everything is pluggable in interfaces, therefore that you easily can swap stuff. Because we didn't know which unikernel is the one to win, it's a very new market, we're just supporting whatever, all of them, right? So we, out of the box, support OSV and RAM kernel. And IncludeOS, it's a startup in Oslo that decided that they were really excited about Unik. So they had their own implementation, and OCaml and Mirage.os is the Docker guys, right? And basically, they added support for Unik. Besides that, after you actually build it, you need to run it. We're also going to take care of that. So we supporting provider. So what is the provider that we support today? QEMU and VirtualBox, if you want to run it on your laptop. AWS, OpenStack, actually, again, the guys from Oslo is doing it right now. vSphere and Futon, it's the next generation vCenter of VMware. We support that as well. And the last thing is also VirtuStream. VirtuStream is EMC Cloud. The reason we support it, it's interesting enough with AWS, in AWS, the way you're actually running instances, the limited volume that you can attach is 1 gig. As I said, unikernel, it's like meg. There's no point for me to pay for the gig. So it's not really working, right? It doesn't make sense to run unikernel on AWS. VirtuStream has this patent micro VM. They're going to take it, you will pay as much as you use, which make it a very, very good cloud to run a unikernel. The last thing is that I'm a big believer that unikernel, because of the strict quality of being very, very small in terms of size, being very good performance because there's not a lot to boot, and also very secure, it's a perfect fit for Internet of Things. So for my opinion, this is the direction, right? Like, it's going to probably be successful on the cloud. It will take a little bit more time. But for Internet of Things, there is nothing better than this. And therefore, we wanted to support ARM, because most of the embedded devices is running with ARM. So I will show a demo soon. So Unik has a Twitter account. And I just wanted to show you that the community basically is trying to build Unikernel for us, right? So this is an example of someone who wanted to build an H base. For that, we're going to do a unique hub. It's because not always the guys who's building it is the guys who are running it, and we want to create a community here. We want people to share the Unikernel. So that's why very soon you will have the Unikernel. We're working on the Unique Hub right now. OK. So that's very cool. But I'm a big believer that no one is running greenfield. And therefore, we need to play very nicely in what it already exists. So the first thing that we did is integration with Docker. And here is why. It seems that the community actually really like Docker. They really buy into their API. So I don't want them to need to learn a new API. So what we did, we basically teach Unik how to speak Docker API. So there is the -h flag that you can today basically point on a daemon that it's Docker daemon that is outside your machine. We use that. If you're targeting a unique daemon, what will happen, you basically will be able to use your script that you ran before, but run Unikernel instead of Docker container. So that's one thing that we did. The second thing that we did, and that, by the way, was always our goal, is to integrate it with Cloud Foundry. Unik is like Docker, right? So it can spin up Unikernel. But if we lost this Unikernel, we lost it. No one will monitor it for you. This is where Cloud Foundry actually is very powerful, right? Because if you lost one, it will bring it back. And you can leverage a lot of their very great stuff like the router and the load balance and so on that they can give me out of the box. So in the beginning, we did an interesting implementation. But actually, we are going to open source today. We basically build a build pack for Cloud Foundry. So that means that you can use whatever you want. Your regular Cloud Foundry, I will show a demo with PWS. But you can run it with any version that you want. Just use this build pack, and it's going to do that. So again, if you go into this, it's open source. Just go ahead and have fun. I will send it after it. So one sec. So let's do demo. OK? OK. Do I need to make it bigger? It's good? It's good, you see? A little bit bigger? OK. OK. Perfect. So what do we have here? I have a machine. And in this machine, I can just run the command Unik. And this is what we're supporting today. You will look at it. It's like so easy to use and simple. It's very simple to use. It's like self-learn. What we're going to do right now is we will see if I have already a Unikernel before. So for that, I will use images. And I see that I have 2 already built ahead of time. Let's see if I'm running any of them right now. And no, I'm not running any Unikernel. So what we're going to do right now is let's use one of the ones that I already built. And I want to show you how quick it is to spin up the Unikernel. So for that, we will do unique one. So what am I doing here? I'm just running Unik. I'm giving the instance name. So I want to call it edit space. And I'm going to give the image name that I built before. And this is the Node.js that you saw before, right? So I'm going to run it. And that's it. It's running. So this is specifically running on AWS. If we will go and do PS, we can grab the IP address. Go to regular browser. Just put it. It's on 8080. And in a second, hopefully, you will see it running. Huh? What did I miss? That's after I build it. It's an AMI is there, right? So when you're building it, you're creating an AMI, and run it basically spin up the AMI, right? But what did I do? Did I do the IP address not right? It was? Really? Let's see. Yeah, OK. So this is what I see. So this is a website written in Node.js. Forget about it. Just wanted to show a website. I thought it's a cool website. Running right now. Unikernel, by the way, just let's look at it, how big it is. So if you're looking again on the unique image, you will see that it's 56 meg of a website, right? I don't know, something like that running in somewhere else. So that's the cool thing, right? So now, what we're going to do is two things. First of all, I'm going to show you how easy to build it. But before that, let's go and spin it up with Cloud Foundry. So, OK. So what I'm going to do right now is cf apps. What you will see is that I don't have any application running. So what I'm going to do right now is cf push. And look what I did here. I'm just giving the build pack that I want, right? minus b build pack and the manifest that I want to run, right? That's simple. And I'm running it. And it's failed. Why? Because I'm not in the right directory. Sorry, guys. There's no manifest. So to be in cf. Now it should work. OK. So now I'm building. This is specifically a Spring application. You will see it build, run. The regular Cloud Foundry, like you know and love. Second, it will run.
Can you show how you do the image?
Yeah, I will. So let's do this. And Cloud Foundry will build it. And then I will go and I will build the image, OK? So now let's just build an image. Unik Build. So this is an example one. I just need to be on the right directory. Give me a second to get to the right directory. OK. So Unik Build. So what do you do in order to build it? Minus the path, right, of the directory where you have that. Minus compiler. So as I show you in the picture, there's compiler and provider. Compiler is, for instance, when you're running on AWS, you basically compile Zen, right, drivers, and you're running on a provider of AWS. So this is what you see here. So the compiler is rump kernel, which is the Unikernel, Node.js. This is the language that you're running on AWS. And your provider name is AWS. Then we will build it. And this is basically all you need to give. While that's doing that, let's go see. And it's failed. What did I do? I need to give a different name of image. 1 second. I need to give a different name of image.
So is the compiler the one that chooses the right packages and modules to extract from the kernel?
So this is, let me show you. When you're going to Unik, you're doing Unik. Then you can do compiler. This is what we support today. I hope that's what you ask. But basically, yeah, so basically this is what's supported today. And the way it's working, as you can see, you have, for instance, include OS, which is the company that I described. It's include OS image, CPP, which is C++, QEMU. And the same thing for VirtualBox. And then you see the Java, we're using OSV, Java, AWS. Yeah, it's going to remove everything. And it's all very cool, like the way we're doing it is container, that building all of this. It's very, very clean, no dependencies. So to install Unik, it's seriously like 2 seconds. Git pull, you need a make, it's working. So as you see, Cloud Foundry finished. So if we will do right now, Cloud Foundry apps, you see one running. This is specifically is in PWS. So if we will go here to PWS, to my account, and probably we need to refresh it. And to authenticate. So what you will see, this is PWS. It's running on AWS, right? Pivotal Web Services, you see one instance running. We can go to it. So this is Tomcat, and specifically the application that I'm going to run here is one that I think this audience maybe know, Pet Clinic Spring Boot, right? So basically, I'm running an application of Spring inside Unikernel and the cloud. The cool thing is right now with Cloud Foundry, we can be very nice and basically scale it, right? So we can do CF scale -i, 4, and the name of the application. And again, Cloud Foundry giving me all of this, right? And basically going to work. So now if we will do up, we will see 4 instances of this application. And that's basically it. So now, let's go right now to Unik. If it's still building, I will need to get a new one. How did we create the Cloud Foundry? What do we really doing there? The magic? So the way we're doing is this. We basically, when you're building it, there is a binary, a Go little binary, that we're putting it inside a container.
I got the Cloud Foundry part of it. I'm saying, how did you create the Cloud Foundry just to run the image? So is there an image?
Yeah, so that's what I'm telling you. So we're taking this piece and we're running it inside a container. So this thing, we call it instance manager, inside a container. It's nothing. It's basically a very small application. What it's doing, it's basically create the Unikernel. It's proxy to the Unikernel that fit in it, because the Unikernel is not running on your cell, right? It will run outside because it's a VM. So we proxy the Unikernel. We also streaming the log. So we're basically creating kind of like a channel between the Unikernel and Unik. So if one of them is dead, and that's what I will show, the other one will die. So for instance, right now, what I want to show you is that if I will do Unik, and also we're getting the logs, right? Because we stream constantly the logs. So if you will do CF logs, you will get the information. So what I want to show you right now is that right now I have 5 Unikernel running, right? So one of them is edit space, right? This is the Node.js one. The other one is basically the regular Unikernel that Cloud Foundry did. What I'm going to do right now, I will delete one of them. I will do Unik, delete. Yes, but there is something that's running inside container that basically manages it outside. Yeah, you're right, because it's VM, right? There's no point, right? It's running directly on the hypervisor. It's not running inside a cell. We can do that, but it doesn't really make sense, because all the point with Unikernel is that it's very, only what you need. I don't need the operating system there. So there is, as I said, there is this instance that when it's, yes, it's proxy. Yeah.
How do you maintain the security model? I mean, typically if you deploy it on a Diego cell, you have a whole layer of security that is managed by Cloud Foundry directly with application security groups and a number of things. How do you maintain that here?
But you don't really need it here, right? Think about it. In the end of the day, it's a VM that's running. It's very, very secure and isolated. It's a Unikernel, so it's even more secure and isolated. All these things, I don't need it here.
I don't know, but I can hit those addresses directly now. They're in the open, right?
Yes, in that case. Yeah, if you have Unik. But the Unik not supposed to be installed to them. Okay, so what I'm doing right now is I'm just killing directly one of the Unikernel to show you how quick we're going to recover for it. And I'm not recovering for it. What did I do? I don't know how to spell, maybe. Okay, so now I deleted one, so we will see that we lost one of it, right? We have only 4, the one and this, and in a second it will come back. Cloud Foundry will return, and here you go, it's pending and it's starting. So that's one thing. So the only thing that we need to do is, so first of all, the image that we build is done, right? So right now, if I will do Unik, you wanted to show how to do it. So if we'll do right now Unik images, you will see right now the images, 3 images, right? Another Node.js application that I built. The last thing, and I don't know if we have time, wanted to show you something cool. What we wanted to do is basically show you how it works with the Internet of Things. So what we did, we have a toaster here, regular toaster that I bought in Amazon. I have bread that I bought from Starbucks this morning. And what I want to do is basically make Unik make us toast. So what I'm going to do, in a second, if this will close, is that I connected this, I don't know if you can see it, but I connected a toaster to a switch and connected it to a Raspberry Pi, okay? What we're going to do right now, we're basically going to make sure that we're going to you make Unik running as a toast. For that, hopefully there's not a lot of time. That's one thing. Okay, cool. And now we did this strange website. Hopefully I didn't destroy it. Yeah. So what we're going to do right now is I'm going to ask Unik to make me the toast, and hopefully we will have a toast real soon. So what I did right now, I click a button and basically said, please make me a toast. Hopefully soon, the switch will turn. We were using U-boot in the Raspberry Pi, which means that basically it's like a Pixie boot for Raspberry Pi. It's coming up, streaming the Unikernel to it, and hopefully in a second it will work if I didn't do anything wrong. Come on, soon. Work, buddy. Yeah, I don't know. For some reason it's not working. Well, because we don't have time, I don't think that we will be able to complete this. Yeah, so we will see if it will work, but we need to finish and wrap it up here. So let's finish by saying, yeah, I have to finish. So just wanted to say this is an open source project, so you can take it and it should work and do quite of crazy cool stuff with it. And as I said, we're building a community around it, so it would be very great if you can help. And I owed you a demo because for some reason it's not working. Sorry about that. Okay, thanks.